Mobile communication, it can be divided in the four types: fixed and wired, fixed and wireless, mobile and wired, mobile and wireless. Fixed and wired. In fixed and wired configuration, the devices are fixed at a position and they are connected through a physical link to communicate with other devices, for example desktop or computer. Fixed and wireless. In fixed and wireless configuration, the devices are fixed at a position and they are connected to a wireless link to make communication with other devices, for example communication towers, Wi-Fi, router. Mobile and wired. In mobile and wired configurations, some devices are wired and some are mobile. They all together make communication with other devices such as laptop. Now mobile and wireless. In mobile and wireless configuration, the devices can communicate with each other irrespective of their position. They can also connect to any network without the use of any wired devices, such as Wi-Fi dongle. Fixed versus wireless network in mobile computing. Fixed and wireless network are both used in mobile computing. Fixed networks commonly operate on radio transmission to connect established wired communication system. Let's talk about the differences between fixed and wireless network in mobile computing. The difference between wireless and fixed network can be distinguished as the wireless networks do not require any cables to make a physical connection with the devices. It is easily accessible because it is shared medium. On the other hand, in the case of fixed networks, a physical configuration of devices is mandatory to perform data transmission. In this medium, we can connect every new device separately and physically to the network. In wireless network, there is no requirement of any physical configuration. In fixed network, a physical configuration is required in any condition. In wireless network, the data loss rate is high. In fixed network, a perfect link is established between devices, so the data loss rate is very low. In wireless network, the data transmission rate is comparatively low as it provides less speed. But for fixed network, the data transmission is high. It also provides high speed. When latency is concerned in wireless network, it's high. For fixed network, there is no issue of latency. The wireless network may be hacked. That's why the security is always low in this type of network. In fixed network, it's highly secured. The issues in mobile computing. There's a lot of advantages of using mobile computing technology. It provides vast features from mobility to portability and from cloud to productivity. But along with these advantages, we can face specific eye-catching issues while using mobile computing technology. Mobile computing is costly due to wireless medium. Mobile computing technology mainly focuses on the wireless infrastructure, so the cost of implementation is always high. There's issues due to device mobility. The device mobility is one of the most significant advantages of mobile computing technology, but it is one of its major issues as well. To obtain the device mobility feature of mobile computing technology, we have to install the highest standard type of equipment. So whenever the mobile device changes its environment, we have to restructure its configuration environment. There is security issues in mobile computing. There is an undoubtedly the biggest and one of the most discussed issue we face in mobile computing technology. It arises due to sheer medium ability of mobile computing. The most significant security issues are physical security or data security and the system security or network security. And these issues can be resolved by using common tactics. And these issues are using VPN technology, using cryptography and network security, and use of firewall technology. Multiplexing can be classified into the four types: frequency division multiplexing (FDM), time division multiplexing (TDM), code division multiplexing (CDM), and space division multiplexing (SDM). Frequency division multiplexing is inherently an analog technology which specifies the frequency dimension spectrum, which is split into smaller frequency bands. It combines several smaller distinct frequency range signals into one medium and sends them over a single medium. In FDM, the signals are electrical signals. For example, in cable TV, we see that only one cable is reached to the customer's locality, but the service provider can send multiple television channels or signals simultaneously over that cables to all customers without any interference. The customers have to tune to the appropriate frequency channel to access the required signal. The advantage of FDM, it applies to both analog signal and digital signals. It also facilitates to send multiple signals simultaneously within a single connection. And the disadvantage is it is less flexible and the bandwidth wastage may be high. Time division multiplexing is a digital and analog technology that uses time instead of space or frequency to separate the different data stream. It is used for a specific amount of time in which the whole spectrum is used. The advantage of TDM is it facilitates a single user at a time, it is less complicated, and it has a more flexible architecture. And disadvantage of TDM, it is not easy to implement. Code division multiplexing, it allows a unique code to every channel so that each of these channels can use the same spectrum simultaneously at the same time. And the advantage is it's highly efficient and it faces fewer inferences. The disadvantage of CDM is the data transmission rate is low and it is complex. When space division multiplexing is concerned, it is called a combination of FDM and TDM. It passes messages or data parallel with the use of a specific frequency at a specific. It means a particular channel will be used against specific frequency band for some amount of time. In SDM, the data transmission rate is high. It uses time and frequency bands at its maximum potential. And the disadvantage of SDM are it has inferences that may occur at any time. It faces highly inference losses. Modulation in mobile computing. Modulation is a process of mixing signals with a sinusoid to produce the new form of signals. The newly produced signals has certain benefits over an unmodulated signal. Mixing of low frequency signals with a high frequency carrier signal is called modulation. Modulation is a process of converting one form of signals to another form of signal. For example, analog signals to digital signal or digital signals to analog signals. Modulation is also called signal modulation. For example, let's understand the concept of signal modulation by a simple example. Suppose an analog transmission medium is available to transmit signal, but you have a digital signal that needs to be transmitted through this analog medium. So, To complete this task, you have to convert the digital signal into an analog signal, and this process of conversion of signal from one form to another form is called modulation. Modulation is used to make the message carrying signal strong to be transmitted over a long distance and establish a reliable communication. A high frequency signal can travel up to a longer distance without getting affected by external disturbances. In modulation, these high frequency signals are used as a carrier signal to transmit the message signal, and this process is called modulation. In modulation, the carrier signal's parameters are changed according to the instantaneous value of the modulating signal. There are a few advantages of modulation. The range of communication is increased, the reception quality is immensely improved, the receivers are allowed to adjust to the bandwidth, the multiplexing of signals occurs, no signal mixing occurs.